Hi, welcome back. So let's have a quick first look at generating and creating classes. In principle, creating class, it goes as simple as defining the keyword class and then define the name of the class. And in convention, we use the capitalized letter for every new word. Now, in practice, the statements inside the class definition will usually be function definition, but other statements are allowed as well and sometimes useful. We will come back to this later. Now, let me show you something called the class object. And class objects support two kinds of operations: attribute reference and instantiation. Let me show you an example actually by creating a real class here. I will call it my class. And basically I could follow the convention by describing by triple quotation as a documentation. And then I could define first a variable. I'll call it I and give it just any value you like. And then you can define maybe a function, just like our standard way of defining a function. Now, the only difference here, this function, even it doesn't take any argument, we must include something called the self. And self indicate that this function, it inherits most of the attribute or access to my class. So this is the only difference by creating standard normal function. So basically, if I would have to say my class dot I or my class dot class function will actually give me to access the value from both either the variable or the functions. Also, the documentation, a valid attribute that I can return the doc string belong to that class. In other words, if I would have to say, for example, my class just like so, and then use the built-in doc string, you could get back the description or the doc string about that class. Let's learn about something called the class instantiation in this case. In particular, if I would have to create, for example, x as a variable, and I say x is actually my class, just like so. This is called a class instantiation, which use a function notation. Now, create a new instance of the class and assigning this to a local variable like x. This is the practice that we would do most of the time. The instantiation operation, or calling the class object, creates an empty object. Therefore, a class may define special method named the init. In other language, we call the constructor function. And this function always will have the special name init, just like so, and then it will have the self as we said, and then init will be, for example, self.data equal to an empty string, something like that. So basically now every instantiation I would have to create afterwards automatically will invoke this init for the newly created class instance. Now, of course, the init method may have argument for greater flexibility. Say, for example, if I would have to in init here, I'm gonna have to receive two different values, for example, width and height. I'm going to create or instantiate a new object, and once I instantiate that, it expects me to pass two values, the width and the height. Now I have access to the W and H based on the values that I've just passed. So if I would have to print this, you get the values that are expected by 5 and 10. Now the next thing we would like to talk about is something called class and instance variable. Instance variable are for data unique to each instance, and class variable are for attribute and methods shared by all instances of the classes. Now I have a variable class called iClass, and I define the init in here. Now what we could see here that var class will be shared by all instantiation variables. However, every instantiation class, every class will have its own different or unique values of W and H, depends on the definition. Now, this is something you have to understand in principle to avoid making a mistake while you are dealing with classes. Let me show you a real practical example. Let's assume here I'm going to create, in this case, just like I list, just like that, just an empty list. Okay, basically I'm going to create a function here. I will say it, for example, to add iList, and then what it does basically, it just go to the self.the iList and append to it the value that it been used. Happen after I instantiate the x and y. X dot add iList, because I can access now that one, and ask me to add a value for it. For example, I will add a string. The other instantiation of y I will say that I list, and I'm going to say this is from Y. Now, if I would go and print, so here X has its own value of 4, which has been in the case of instantiation have been assigned, and Y has its own. However, when we printed the list, this empty list, watch carefully, it was actually adding whatever operation that we have done. If every instantiation I added in here and I used the built-in function to add I list, it would be actually added to the big list, so it will be a big dump place in here. And this is a very wrong approach that you can use actually. But the right approach, it shouldn't be actually just like that. It should be something completely different. So what I could do basically in it, which the function can be invoked by every instantiation, and then I could create, let's say for example, the I list in here, and it's an empty. And I would have to run the exact same example as before. I will get the desirable result. So here the I list for X, it will be only whatever I have operated on. So if I would have to come back here and say once again X dot add, so this will be dumped only to the X instantiation. Now it's a time to be looking at random remarks. I will see you then.